Yes. Today we will cover the conversion of any context-free grammar to Chomsky's normal form, which is the most famous form. Context-free grammar, we have discussed in last lecture that it is which is very close to our programming languages. In fact, all the programming languages, 98% to 99% is as per the go for deterministic context-free grammar. But here we have both classes, deterministic context-free grammar and non-deterministic context-free grammar can be converted to Chomsky's normal form. What is basically Chomsky's normal form is left hand side should be single variable only, no context, that is called the context free. Right hand side only two variables or a terminal. There will be no epsilon, no variable other than start variable can go to epsilon. If there is epsilon in the language, then it can go only reachable from S start variable to epsilon. This is the Chomsky's normal form. What is the advantage? That we can use the binary tree. We cannot have any more branches, only maximum 2 branches. What is the advantage? Parser, that is, it can use binary trees. What is the parser? Whenever you write a program, first is go for token analyzer, it creates tokens, and then syntax analyzer is okay, then it goes for the parser. Parser can use the binary trees. And exact length of the derivation is known. If there are n symbols, maximum it can go to 2 main minus 1 steps, maximum. That is, that is a linear relationship. Let's say example, say you have this context-free grammar, and it appears this context-free grammar is as per the Chomsky's normal form. But if you look closely, it is not Chomsky's normal form. Because why it is not there? Because you see here the V variable cannot go to any terminal. B, capital B, no terminal. So this is a useless symbol. Then we omit these two. You have to totally omit where there is a B rule. Then the rules comes S to A. This also looks like Chomsky's normal form. But here you see the A variable you cannot reach from start. So you have to omit these rules also. So this 1B is useless symbol and A is unreachable symbol. So you have to clear all these rules. The rules only there S to A. So this is the context-free grammar, and as per the Chomsky's normal form. But basically, you clean the grammar. Before any normalization, you have to look for any useless symbol or not, whether any unreachable symbol. You clear the grammar for all these rules, then here go for Chomsky's normal form finally. Here is practice another grammar. This is and it appears is also again a mainly Chomsky's normal form, only barring this. Anyway, let's see the B variable again. Also see B variable. It cannot generate to any terminal. So again you have to omit these rules. Then you have only these 3 rules. S to C, A to C. This is as per the Chomsky's normal form. So you don't have to do anything else. And you are fortunate that your start variable don't appear on the right hand side. Then you have to more broader rule, more elaborate arrangement should be there. You have to take a new start symbol. Let's try. Again, another practice. See here it's a long rule, and here you have a rule. It is not Chomsky's normal form, but it violates Chomsky's normal form. So here we can do what you can take a new variable D here. So you can take a new variable, say S to DC and D to A. Then it's this, but then you have a ABC, these two. Then you take E here, S to AE and E to BC. Then it is a Chomsky's normal form. So finally rule is S to AE, E to BC. So if long variables are there, you make it that way. And another thing, you little tweak change it here by changing this rule A by new variable D. Now this is a Chomsky's normal form. But again, there is no S symbol on the right hand side, so you can manage it without have a new start symbol. Next stage. Here also we are trying to convert it to a Chomsky's normal form. Here you also see there is no right hand side, no useless symbol here. No non-reachable symbol is here. So this is a palindrome, null palindrome. This is a non-deterministic context-free grammar. but it is not as per Chomsky's normal form. You just simply put instead of this small terminal, you create a new variable here and those things. Then you can all this last 6 rules as per Chomsky, and this is you just make this long variable, make another new variable here, then we can make it Chomsky's normal form very easily. You see the next slide. Here we have done this. What we have done, we have taken a new this ASA, we have taken the, instead of SA, we have taken a R1 to SA. And here we go for this BSB, here we also taken the R2 is equal to SB, and there is to be. So we have ultimately here 4 and here is 6. So we have a 5 rules and you have a 10 rules, but it's much simpler for parser. So in any book you can find it. If there are n rules, maximum in Chomsky's normal form, it can be maximum n square, not more than this. So maximum limited n square. But this rules is much simpler. So what is the algorithm? The algorithm is whether first step is you have to get rid of a non-reachable symbol, useless symbol. Then you have to take new start symbol if there is any start variable on the right hand side, and then you have to go for eliminate all epsilon rules because as per Chomsky's normal form, no other variable goes to epsilon, only start variable can go to epsilon, and that you have to take each variable one at a time. You have to take one at a time, then eliminate all unit rules, then eliminate all mixed rules. So if there is a variable and terminal, then you have to make both the right hand side should be 2 variable or single terminal, and eliminate long rules. Let's try the example. This is our context free grammar. It appears very simple, but you have to make a context free because Chomsky's normal form, because here are 3 variables. This is not as the Chomsky's normal form. This is also have to make. So first we have to take care of it, that we have to check whether any useless or unreachable symbol is there. There is no such symbol here. Every variable is reachable. And here you see the main problem is here you have to take S comes on the left hand side, also on the right hand side. So then you have to take a new start symbol, that is S0 to S, and this is the first stage. You take a new incorporated new S0 because S appears on the right hand side. Then the rules come this, and here you see the B to epsilon. We have to remove B to epsilon, and you have to remove this rule, and where the B can go to epsilon, you have to incorporate this. So after removing B to epsilon, you remove this rule. Then because B can go to epsilon here, then A can go to epsilon here also. And here you have say S to SA, AB, and because B to go epsilon, so it can be say S0 to S. So this is the after removing the B to epsilon. Then after removing B to epsilon, we have a new rule A to epsilon. So we have to remove A to epsilon in the next stage. So that we have done it here itself, because A to epsilon here, because SA, here AB is there either, then one A can go to epsilon, so SA, and this A can go to epsilon, AS, and both A can go to epsilon to S. So 3 more rules added here. Then the next stage we remove A to epsilon rules also. Here we see it. So you have come to these rules. Here B to epsilon rules is removed, A to epsilon rule is removed. Now we have to remove these 2 rules. Single left hand side is single variable, right hand side also single variable. These 2 rules we have to remove. So after removing these rules, you come to first I remove this rule S0 to S, and to remove. Next stage is we have to single variable rules we have to remove. Yes, this rule is coming. S0 to S. This is. Now we have removed the epsilon rules also and single variables. After I just remove this A to B and A to S. See here we have a long variables. We have to take a new variables, like we have to take, instead of A1 is SA, because we have changed the rule ASA to A1 and A1 to SA. Like this, these rules, then we come to these rules, and you can see it, you can appreciate it. This is Chomsky's normal form. Almost we have reached. Okay. So this is the our CFG, and this is the Chomsky's normal form. You see left hand side single variable on non-terminal, right hand side two variable on non-terminal, and no variable on the can go to epsilon, because S0 can go, but here it is not generated, so S0 cannot go to epsilon here, and this is the algorithm. So first you get rid of all useless and non-reachable, then if the S starts on the right hand side, then take for new star symbol. If it is not, then you don't have to take new star symbol, but it is always safe to take a new star symbol. Then eliminate all epsilon one at a time, eliminate all unit rules, eliminate mixed rules, eliminate wrong rules. I think I can make understandable to you. Thank you very much.